Assalamu alaikum. This is Muhammad Mahid Khan Amir, lecturer in mathematics, EMDS, Rajaguttura Model College. Today our class is on general mathematics for class 9 and 10. Our today's topic of discussion is factorization, which is of exercise 3.3, and this is our first lecture on exercise 3.3. As the chapter is about factorization, the first thing we will learn is resolution into factors, or just factors and factorization. If an expression is equal to the product of two or more expressions, each of the latter expressions is called a factor of the former expressions. Suppose we have 12. If we want to break down 12, we can have 3 into 4 or 2 into 6. Here 3 and 4 or 2 and 6 are the factors of 12. After finding the possible factors of an algebraic expression and then expressing the expression as the product of these factors are called factorization or resolution into factors. Suppose 12 is equals to 3 into 4. So the process of 12 from 12 to expressing it into 3 into 4 is called the factorization. The algebraic expressions may consist of one or more terms, so the factors may also contain one or more terms. Here 12 was only one term, and 3 and 4 are factors with one terms. But if we think about a square minus b square, here we have got two terms, and if we apply the formula of a square minus b square, that is equals to a plus b into a minus b. Here we got the factors a plus b and a minus b. In both the factors, it contains two terms, a and b. So this was the example of factors containing one or more terms, or normally the terms of the factors. Now we want to find out the factors of a given expression. There are many ways. Let's see some process of resolving expressions into factors. The first one is common factor. We know very well what is common factor. Suppose we have three terms in an expression like AB plus BC plus CA, or AB plus AC plus ABC. Here in all the three terms we have got A common. So the terms which is in all the terms of an expression is called the common factor or common terms. So if any polynomial expression, obviously the expression must be a polynomial, because if the expression is nominal or just having only one term, there is no possibility to be or to find out common factors. So that's why we must need an polynomial expressions. So if any polynomial expression has common factor in every term, at first they are to be found out. For example, suppose we have a expression given 3a square b plus 6ab square plus 12a square b square. We can see the coefficients of the terms are either 3 or multiplied by 3. So 3 is a common factor of them. Then all the three terms we have got a and a b. So our common term here is 3ab, as in all the three terms we have 3ab. So now we want to make 3ab common, or take 3ab as common. So we can write 3ab. Now 3a square b divides 3ab is equals to a. So our first term becomes a. Then 6ab square divides 3ab, its results 2b. So our second terms become 2b, and 12a square b square divided by 3ab is equals to 4ab. So the finally last term becomes 4ab. So the given expression has now become 3ab into a plus 2b plus 4ab. Now here we got our factors 3a, b, and a plus 2b plus 4ab. 3ab, this is one term, and a plus 2b plus 4ab, this is a three-termed factor. So this is the process of taking common factor or using common factor process of resolving expressions. Now the next one is perfect square. I guess we all know what is perfect square. Perfect square is if we square root a number, then if the result is a whole number, then the given number is called a perfect square. Or in one line, we can say if the square root of a number is a whole number, then the number is called perfect square. So similarly here, an expression can be expressed in the form of a perfect square. For example, resolve into factors a square plus 2ab plus b square. Here we know a square plus 2ab plus b square is the formula of a plus b whole square. So we can write it a plus b whole square. Here now we got almost our answer. We know a square is equals to a into a. So similarly, applying that way, we can write a plus b whole square equals to a plus b into a plus b. So this is the procedure of perfect square method. Now our next method, next process is difference of two squares. Expressing an expression in the difference of two squares and then applying the formula a square minus b square is equals to a plus b into a minus b. In this process, the given expression, we need to reshape it, rewrite it, and we have to make it in the difference of two squares, like a square minus b square. Then we have to apply the formula of a square minus b square, what will be a plus b into a minus b. This is how we can get the factors by the process of difference of two squares. Now the next process, which is middle term factorization. This is very important and common factorization process. Factors can be determined by applying the formula x square plus a plus b into x plus ab is equals to x plus a into x plus b. This was actually the formula we have learned, the fourth formula of algebra. X plus a into x plus b equals to x square plus a plus b into x plus ab. Here we will just apply the formula from the reverse way. So in this method, a polynomial of the form x square plus px plus q can be factorized if two integers a and b can be found, so that a plus b is equals to p, which is the coefficient of x, and ab is equals to q. Q is the constant term. For these two factors of q, with their signs are to be taken, whose algebraic sum is p. So here we have to factorize q first, as we have factorized them in the arithmetic. So in that way, we have to factorize them and find or select two factors of q such that their algebraic sum will be equals to p. Now q can be positive or negative. There is a question, or there is some terms. What will we do if q is 0, q is greater than 0, or q is less than 0? So if q is greater than 0, a and b will be of the same sign, and if q is less than 0, a and b will be of opposite signs. To be noted, p and q may not be integers or may not be integers. So for example, x square plus 12x plus 35. So here we have got it in the form of x square plus px plus q. Now we have to factorize the constant term. Here the constant term is 35. So we want to factorize it in such a way that the sum of the factors will be equals to 12. And as the constant term is greater than 0, so the factors will be of the same sign. There are many factors of 35, 1 and 35, then 5 and 7. So if we take plus 5 and plus 7, it is equals to 12. So we can write it like x square plus 5 plus 7 into x plus 5 into 7. Then we can easily write x plus 5 into x plus 7. So this is the formula or process known as middle term factorization. The next one is middle term breakup. Middle term factorization and middle term breakup are almost similar. There is only one thing different. So by middle term breakup method of polynomial of the form ax square plus bx plus c. Difference is here. In the previous math, we had x square plus px plus q. That is, we had, or the coefficient of the x square term was 1. Now we have a coefficient of x square which is equals to a. So by middle term breakup method of polynomial of the form of ax square plus bx plus c would be ax square plus bx plus c equals to rx plus p into sx plus q. So here the factors will be rx plus p and the sx plus q. If, now here comes the condition, x square plus bx plus c is equals to rx whole rx x square plus rq plus sp into x plus pq. That is, here a will be equals to rs, b will be equals to rq plus sp, and c will be equals to pq. Hence ac equals to rs plus rs pq, that is rq into sp, and b, which is rq plus sp. Therefore, to determine factors of the polynomial ax square plus bx plus c ac, that is the product of the coefficient of x square and the term free from x, are to be expressed into two such factors whose algebraic sum is equals to b, the coefficient of x. If we want to relate it with the middle term factorization, or if we want to find the similarities between middle term breakup and middle term factorization, we can see that in middle term factorization we have factorized q, the constant term, only the constant term, but in middle term breakup method we have to factorize the product of constant term and the coefficient of x square. So that is ac. This is the only difference between the middle term factorization and middle term breakup, and the rest part was same. We have shown that the product, the factors, their sum, algebraic sum, will be equals to b. Here similarly for middle term breakup, almost same. The factors, the summation of the factors will be equals to b, and the sign are also same. If the constant term is greater than 0, then the factors will be of same sign, and if the constant term is less than 0, then the factors will be of different signs. If we want to see an example, we can see 3x square minus x minus 14. Here the coefficient of x squared is 3 and the constant term is 14. So we have to factorize 3 into 14 is 42. So we have to factorize 42. We know 7 and 6, 7 into 6 is equals to 42, and minus 7 plus 6 is equals to minus 1, which was the coefficient of x or the value of b. So we have got 3x square minus 7x plus 6x minus 14. So if we want to take the x common, we can write x into 3x minus 7, and in the last two parts we can take 2 common, so 2 into 3x minus 7. Now we have got 3x minus 7 common, so taking that common we will have 3x minus 7 into x plus 2, or x plus 2 into 3x minus 7. We have no problem whether we have write our first factor or just change the position of the factors. There is no problem, as this is multiplication, and we know in multiplication ab is equals to ba, so there is no problem with the position of the factors. The next method, perfect cube method. This is also like the perfect square method. Factors can be determined by expressing an expression in the form of a perfect cube. So we will be given some expression and we have to reshape it into the formula of a plus b whole cube or a minus b whole cube, from where our answer will be something like a plus b whole cube or a minus b whole cube. So let's see. For example, a cube plus 3a square b plus 3ab square plus b cube. We know this is the formula of a plus b whole cube, so we can write a plus b whole cube. Then as a cube is equals to a into a into a, and to factorizing a cube we had to write a into a into a. That's why we will write a plus b whole cube equals to a plus b into a plus b into a plus b. The next one, the next process of resolving expressions into factors is formula of addition or subtraction of two cubes. When we were doing the calculation with squares, there if we have a formula when we have the subtraction of two squares, a square minus b square, which was equals to a plus b into a minus b. There we found two factors. But when we had taken a square plus b square, the formula was a minus b whole square plus 2ab, or a plus b whole square minus 2ab. There was not, we didn't get any factors from there, as there is some plus sign, or there are two terms. That's why we didn't have any formula of addition of two squares. But when we take the cubes, the two formulas a cube plus b cube is equals to a plus b into a square minus ab plus b square. We got two factors, or multiplication of two things. And when we take the subtraction, a minus b whole cube, sorry, a cube minus b cube, we have found a minus b into a square plus ab plus b square. Similarly, here we got the multiplication of two things. That's why we can call them factors. So for that, we have the formula of both addition and subtraction of cubes, but only formula of subtraction for the squares. So let's see what are the formulas. Factors can be determined by applying the formula. I have said a cube plus b cube, which is equals to a plus b into a square minus ab plus b square, and a cube minus b cube, which is equals to a minus b into a square plus ab plus b square. So these are the formulas we have to apply to get the factors from the given expressions. This formula is known as the formula of addition or subtraction of two cubes. The next process, known as the factor of the expressions with fractional coefficients. Now suppose we have an expression where the fractional coefficients are given, or the coefficients are fractional, not the whole number. So we have done till now. So factors of expressions with fractional coefficients can be expressed in several ways. Here we didn't formulate any formulas. Here we have to understand this part with examples. For example, we have a cube plus 1 by 27. This is the given expression we have to factorize. Now we can write 1 by 27 in 1 by 3 cube. So we got a cube plus 1 by 3 whole cube. So 1 by 3 cube can be written into a 1 by 3 whole cube. So from there we can have the formula of the addition of two cubes, that is a cube plus b cube. The formula was a plus b into a square minus ab plus b square. So applying that formula for this math, we will have a plus 1 by 3 into a square minus a by 3 plus 1 by 9. As a into 1 by 3 is a by 3, and 1 by 3 whole square is 1 by 9. So we got two factors, a plus 1 by 3, and the other one is a square minus a by 3 plus 1 by 9. If the further factorization is possible, we have to factorize it furthermore. But here a square, a plus 1 by 3 is its simplex form, and a square minus a by 3 plus 1 by 9 cannot be factorized anymore. So this is our factors. Now we want to do it in another method, which is a cube plus 1 by 27. Now we want to take common the factor part, or the fractional part. We have taken 1 by 27 common. So we will have 27 a cube. As multiply 27 a cube into 1 by 27, it will be equals to a cube. So 27 a cube plus 1. Now 27 a cube can be written as 3a whole cube, and 1 is obviously 1 cube, and 1 is the same thing. So now we have again the formula of addition of two cubes, a cube plus b cube. So the formula is a plus b into a square minus ab plus b square. So applying that formula, we got 1 by 27 to 3a plus 1 into 9a square minus 3a plus 1. Now 27 can be written into 3 into 1. So 1 by 27, we can write it 1 by 3 into 1 by 9. So if we multiply 1 by 3 with 3a plus 1, we will have a plus 1 by 3. And if we multiply 1 by 9 with 9a square minus 3a plus 1, we will have 9a square by 9, that is a square, minus 3a by 9, that is a by 3, and plus 1 by 9, that is obviously 1 by 9. So we got the same results, whatever the method we have chosen. So in the second solution, the factors involving the variables are with integral coefficients, but two solutions are same. We have seen how they are same. So these are the process of resolving expressions into the factors. To do the maths of this chapter, we have to apply these formulas or apply these processes to get our required factors. So that's all for today. In our next class, next video lecture, we will try to complete this chapter, the maths from exercise 3.3. So I guess in these bad days of Corona, may Allah keep all us safe. Thank you, everyone.